Welcome to This Explainer. Today, we're diving into the absolute brilliance of Roman engineering. We're going to tackle a massive paradox that's been driving modern historians and engineers a little crazy. How exactly did this ancient civilization build infrastructure that literally outlasts our most advanced modern equivalents? Seriously, think about it. How is it that our highly engineered modern concrete falls apart, cracking and crumbling in just 50 years? But Roman structures have survived earthquakes, pounding seawater, and 2 entire millennia. When you look at aqueducts still delivering water today, or the Pantheon still dominating the skyline, it hits you. The Romans weren't just building for the next generation, they were engineering for eternity. To figure out exactly how they pulled this off, we're going to break down their mastery into 5 key parts. We'll look at laying the empire's foundation, conquering valleys with inverted siphons, flushing Rome through the Great Sewer, the absolute miracle of Roman concrete, and finally, their crowning glory, the Pantheon Dome.
All right, let's jump straight into part 1, laying the empire's foundation.
So, to build a sprawling road network of 250,000 miles across Europe, Asia, and Africa, Roman engineers couldn't just throw a few paving stones on dirt and call it a day. They developed what's known as the via strata. And fun fact, that's actually the root of our English word straight. It was a highly advanced geotechnical stratification system. Basically, they understood that a road is only ever as strong as the earth beneath it. So they designed these incredibly deep, multi-layered foundations to distribute heavy, dynamic traffic loads and guarantee long-term survival. They literally built these roads from the bottom up, using 4 distinct layers. First up, they'd dig a deep trench all the way down to stable subsoil. Next, they laid down a solid base of large stones. Over that went a layer of smaller, tightly compacted stones or gravel to lock everything in. And finally, they topped the whole thing with a sand or lime surface. But here's the real genius. They engineered a camber. That's a slightly raised center. Because of this, rainwater naturally drained off into side ditches, completely preventing the muddy pooling that ruins modern dirt roads. They weren't just paving a surface, they were building a massive water control system.
Moving right along to part 2, conquering valleys with inverted siphons. When it came to moving millions of gallons of water to metropolitan Rome and its provincial cities, gravity was literally their only engine. But what happens when an aqueduct hits a valley deeper than 50 meters? A standard arched bridge would just become way too structurally unstable at that height. So their workaround was the inverted siphon. They used this ingenious U-tube principle to push water right across deep valleys without using a single mechanical pump. No electricity, no motors, just pure physics.
The Roman author Pliny hit the nail on the head when he wrote, "Water rises as high as its source." By understanding this vital principle of communicating vessels, Roman engineers realized something incredible. If they trapped the water in a perfectly sealed system, the sheer momentum and pressure of the water rushing down one side of the valley would generate enough force to climb right back up the opposite side. The only catch was that the final destination just had to be slightly lower than the starting point. Now, managing all that massive water pressure was a serious, high-stakes balancing act. First, the water pooled into a header tank. From there, it was funneled into sealed pipes, usually made of lead or stone, laid straight down a masonry ramp. When the water hit the very bottom of the valley, it crossed a low venter bridge to spread out that intense pressure before being forced all the way up into a receiving tank on the other side. They even had the foresight to install open standpipes called columnae to vent trapped air. This completely prevented catastrophic blowouts from water hammer effects. Just a flawless, brilliant manipulation of physics. Which brings us to part 3, flushing Rome, and the story of the Great Sewer. You see, building a massive empire also meant handling the waste of 1 million citizens. Enter the Cloaca Maxima, easily one of the world's earliest and most successful sewage systems, and its evolution is wild. Way back around 600 BCE, under King Tarquin the Elder, it started as just an open-air canal to drain some local marshes. Fun fact, draining that waterlogged swamp actually created the dry land that became the famous Roman Forum. Fast forward a few centuries, and it evolved into this massive, covered conduit built from huge blocks of tough stone. By the 1st century AD, the Romans cleverly connected the continuous runoff from all 11 of their aqueducts directly into the sewer. That meant a constant, high volume of water was effortlessly scouring the city's drains all day, every day. Incredibly, parts of this exact same sewer are still functioning in Rome today. Kind of makes you think, next time a modern city pipe bursts, right? Okay, let's get into the chemistry in part 4, the miracle of Roman concrete. This is where we uncover why their building materials have so vastly outlasted our own. The contrast between modern concrete and the ancient Roman recipe is absolutely staggering. Today, we design modern concrete to be inert. We don't want it to react. But that means it degrades rapidly in environments like seawater, and the second it cracks, it crumbles. Roman concrete, on the other hand, they engineered it as an active, living material. It chemically thrives in seawater by producing this rare mineral called aluminous tubermorite. And even crazier, thanks to tiny, highly reactive lime fragments trapped inside, Roman concrete is completely self-healing.
Recent research out of MIT actually figured out how they pulled this off. The Romans used a process called hot mixing. They combined volcanic ash with quicklime at insanely high temperatures. This trapped brittle, highly reactive particles, called lime clasts, right inside the concrete. So picture this. A tiny crack inevitably forms. Rainwater seeps into that crack and hits those trapped lime clasts. The lime dissolves, creates a calcium-saturated solution, and then rapidly recrystallizes as calcium carbonate. It literally heals its own cracks before they can spread. They essentially invented a construction material with an automatic repair mechanism. Mind-blowing, right?
And that self-healing magic brings us to our final section, Part 5, Crowning Glory, the Pantheon Dome. Because of this indestructible concrete, Roman architects could master space and gravity in ways nobody thought possible, peaking with their absolute masterpiece, the Pantheon. Get a load of this number, 5,000 metric tons. That is the staggering weight of the Pantheon's massive, unreinforced concrete roof. To this very day, it holds the title for the largest unreinforced concrete dome on the entire planet. No steel rebar, no internal metal skeleton. Yet, it hasn't collapsed in nearly 2,000 years. To keep a 142-foot wide concrete behemoth from just crashing down under its own weight, the engineers basically hacked physics using 3 genius mass reduction tricks. First, they tapered the concrete mix itself. At the base, they used heavy, dense travertine rock. But as they built higher and higher toward the roof, they swapped that out for light, highly porous volcanic pumice. Second, they literally tapered the thickness of the walls, going from 19 feet thick at the bottom to less than 5 feet at the top. And third, they carved out a coffered ceiling and left a massive 27-foot open oculus, a giant hole right in the center. That eliminated all the heavy concrete exactly where the structural bending stress would have been the most dangerous. But what makes the Pantheon so breathtaking is that they never sacrificed art for engineering. The dome is a perfect geometric hemisphere. Its 43.3-meter diameter exactly matches the interior height from the floor straight up to the oculus. By blending this flawless aesthetic perfection with unmatched engineering, the Romans created an awe-inspiring space that perfectly mirrors the vault of the heavens. It's just gorgeous. When we look around our modern, towering cities today, this deep dive into Roman resilience really makes you question the true legacy of our own engineering, doesn't it? They built structures that literally heal themselves, sewers that flow continuously for millennia, and roads that conquered entire continents. So I'll leave you with this thought. With all of our supercomputers, high tensile steel, and advanced modern tech, what exactly are we building today that will still be standing, awe-inspiring, and fully functional in the year 4000? Think about that for a second. Thank you so much for joining me on this explainer, and as always, keep questioning the world around you.